Talos 110. Let's get going. I'd like to introduce Wade Chen and Sigul Yang from ZenLayer. Well, I'll let you guys introduce yourself. So take it away.
Thanks, Steve. So I'm a VP of our technology alliances. I'm just helping to facilitate this and kind of talk about some unique stuff around spinning up our bare metal clouds, leveraging Talos. The real brains here is the one next to me, Sigul. He's the one that did everything, deployed it, wrote an amazing blog that details, everything on how to kind of deploy that, which you can definitely refer to if I miss anything during this talk. But we're going to go through how to orchestrate the bare metal, automating some Kubernetes clusters creation on demand with our bare metal cloud. So we'll have a couple of stops where we'll take some questions because we think those are important areas that we definitely want to highlight. And then feel free to kind of chime in and ask for clarification. Then we will obviously address those issues. And then let's just have a little bit of fun at doing this. Hopefully you guys enjoy the session. We try to make it as practical as possible based on our experience of deploying this. So without further ado, I will get started. So very quickly, the agenda, we're going to show you how to spin up a bare metal cloud with ZenLayer. We'll do an install of Talos on bare metal and talk about some of the unique aspects of that. Also, we'll very quickly highlight the supported automation. That's a whole other topic that we can discuss, so we'll just very lightly touch on that. The next project that we have in mind, and then we'll open it up for Q&As at the end if there are any. So one of the things is why is this deployment different on a bare metal cloud? And the reason that we feel that way is the infrastructure is running over physical interfaces and VLANs. That makes it similar to an on-premise environment. So you have a little bit more option in terms of the security and performance. So some interesting things to kind of watch out for, which we needed to, is that this requires etcd during a bootstrap for the first controller node to get that set up. So that's a little bit unique. And then all access is via API. There's no SSH access for Talos, which made it a very interesting deploy when we first did this. Also, bootstrap etcd in your private environment instead of using public internet to access and get that set up. There's a unique way to kind of set that up, and that's what we're really going to go over. Some of the reasons, we can leverage a Bastion and our VPC to run everything on your own VLAN. Some of the reasons for this, obviously latency is one of them, especially because we have a lot of presence in emerging markets, China being one of them. So there could be latency issues over long distances as you try to get this set up. Also, in some cases, they may have some privacy concerns, not that relevant, but if you do, then you can run everything within your own private cloud and the VLANs without having to go outside of that environment to get it set up. And that makes it a little bit unique. So what we're going to do first is go over the ZenLayer and our bare metal cloud provisioning highlights. We'll very quickly go over provisioning the bare metal servers on us. And then the second piece is creating the virtual private interface. And then that's the VLANs and attach them to the servers to get your environment up and running. This one I'll go over really high level because it's fairly standard. Most of the people know how to do this. But in our case, you log into the console, you'll choose a region or city that you want to deploy in. You pick the servers and the specs, you'll see the pricing and whether it's a good deal or not, decide if you want to deploy that. Once you do, you can look at the OS that you want from a drop-down menu. We use Ipxe to run and install those. You have RAID and partition options depending on the bare metal server configs. And then you can change the internet bandwidth, and you can also add additional floating IPs if you need to. Typically, because this is a bare metal deploy, the partitioning and the OS will take around 12 to 30 minutes, depending on what you actually choose. And then, boom, your server is going to be up and running. As mentioned, each of the servers is typically assigned a /30 internet IP address. So even though they're 4 IP addresses, they use them for different purposes, as you can see below. Network identifier, gateway, the actual IP address that they'll use, and then the broadcast one. So just a quick screenshot. Once you get into our console, you can select the bare metal instance on the left-hand side. There's quite a few options to do that. We have it in I think, over 50 cities now that you can go in and deploy, and then a couple of different configurations. All of that will be listed out along with the pricing as kind of shown. So the second part I want to get to, once you've spun up these servers, is how you create the VLAN and then attach these to the servers. You can see on the right side, when you spin up the individual servers, all of them have WAN ports and give you public internet access. What we want to do is create the result on the bottom over here, which is going to create a VLAN and attach all of these servers and create that cluster for you, right? So on the overview side, what's going to happen is you're going to look at the private network. You'll select a VPC, select the zone, because obviously you can only create that cluster within a particular physical region. And then we'll pick an IP range, and the subnet will sit in the corresponding VPC. Then from there, you'll go into the subnet, configure the private IP range, and then you'll attach the server to that private IP range. And then you can see some additional details, including MAC address for future setups with DHCP or doing IP and MAC binding. So when you want to create the VPC, once again through the console, you can select the network under the network tab, under the virtual private cloud, label your VPC, and then you're going to select the location for the zone. Hopefully it's the same one where all the servers are deployed. And then you can configure the IP range, right? Once that's done, you can actually go into the subnet, and then on the right-hand side, you'll see something about adding an instance. So this is going to attach it to the server. And once you've done that, you can look at the VPC on it, and then you'll be able to see some details once you click into it. And then that'll give you the VPC information, as well as MAC address, IP address, and all of that fun stuff. To note, PXE0 is the interface that ZenLayer uses for OS installation during provisioning of the OS, right? And once that's completed, this will be converted to your private LAN interface if you choose to set that up. So assume you've done all of that, and you have the host name, and you've applied the private IP address and the subnet. You can then go into the servers and start pinging them, and then just make sure that the private network is up and running. Okay, I'm going to stop here for a second. Hopefully there aren't really any questions, but that one is pretty straightforward. Are there any questions around that to start off with? So if there are, just drop it into the chat, and then we'll try to answer them.
Easy piece.
Yeah.
Thanks, Chris.
Great. That's what we're hoping for. Okay, yeah. So let's move on. Now we get to the fun part, the installation of Talos. We kind of broke this down into, you see a quick question.
Yeah, so BMC usually to be like baseboard management system. It's another name of the IPMI.
Yeah.
That is also the application of the bare metal cloud.
Awesome. Okay, so let's move on to this one, the installing Talos. Well, we broke that up into about 6 sections. Each one of these have something unique, so we can share with that. The first one is you'll need to create an admin workstation that has DHCP, TFTP, HTTP, and then that'll has the PXE and the IPXE server. The second piece is going to be installing the Kubernetes CLI tools on the admin workstation. The third piece is going to be getting the PXE environment ready, doing a DHCP server config, TFTP server, and the HTTP server. And then we can also do a verification check. Fourth step will be generating the machine configuration files for the CP node, which is control plane interface, and also the IP settings, and also for the worker nodes and their IP settings. Fifth one will be actually starting to install with the PXE install and the bootstrap etcd of the first control plane node. Is the only one that's going to need that. Then doing the PXE install for the worker nodes. And then lastly, you can verify the cluster build and do any configuration or modifications. And there's some basic troubleshooting. So once again, the final build topology will end up looking something like this. If you look at the left side, that's the administrator workstation where we, as mentioned, installed the DHCP, TFTP, and the HTTP, as well as the CTLs. That we'll explain why you'll need that later. The first one you see is the control plane, and then you'll set up another 2 of the worker nodes. And all of that also has the private VLAN set up. Okay. So the first thing we want to do as we create the admin workstation and install CLI tools, make sure you have root privilege, run apt install. Actually, you can take a step back. What was this? Is a Linux-based one, right?
It can be running over like either Ubuntu or CentOS.
Yeah, either Ubuntu CentOS. Once you have root privilege, just run apt install and then install the DHCP, TFTP, and the HTTP as listed. That's pretty straightforward. And then the second step is installing the Kubernetes CLI tools. In this case, we did the Talos CTL, kubectl, and then optionally, we are also able to do the cluster CTL. As you can see, the command line is all listed in there. But all of this is fairly straightforward. So now we'll get into the fun part. Configuring the Pxe environment. As we go to configure that, the config file in there is the /etc dhcp and then the dhcpd.conf. We define the range for that as 10.77101 to 150. And then we have the service listening at 10.773 for the private LAN interface. One of the key settings here is going to be to let the DHCP server send the correct file to the clients when they're asking for a DHCP bootstrap. And we put in an if-else statement for this different request. Basically, by default, the Ipxe will issue another DHCP request and run into an infinite loop, which Pxe will load Ipxe, which will load Ipxe, which will load Ipxe, which will load Ipxe. So we need to break this infinite loop. And the server will check if the user class attribute of DHCP is set to Ipxe. And then it'll send out a boot.script instead of the Pxe image if it's initialized by Ipxe. Okay, that was a mouthful, but we have individual slides to kind of go through the important pieces of this, and we'll open it up for questions after this because it's actually pretty important. Under the TFTP server, it's a pretty simple setup, and it just does a single job. It helps the DHCP client initiate the Ipxe boot, and the default configuration listed there. You can find a directory root and put the Ipxe image in it, and then they can be downloaded from boot.ipxe.org. If it's a server with legacy boot, that will serve the purpose. If it's using UEFI, you'll need the ipxe.efi. So this is one of the important parts. We want to break that infinity loop. You can see the user class here is the Ipxe, and then it has the file name under HTTP 10.773, and then that's going to force it to load the boot script file, right? And break that. Break that infinite loop. There we go. Under the HTTP server, once the Ipxe image is loaded, the DHCP client will be able to pull the script via HTTP, and then Talos installation will require the YAML file for the server configuration. And this will also be provided via HTTP as well. So single command line of apt install light TPD or whatever you use will install it. And the default configuration file, as you can see, is under the etc light pd and then lightpd.conf. You can find the server.document root definition, locate the folder, and then you'll want to place some of the files below. I'm not going to go through all of these, but you can see the cp.yaml and then the wk.yaml. Those are going to be for the control plane and then the worker nodes. Okay. So over here, the Ipxe boot script for Talos installation. The boot script is key for the IPX booting. And then that's a mouthful. I'm not going to say it, but essentially you can see the command line that are going to be here. And then this is going to be the boot script that we're going to point to, and it's going to run the configure and run the YAML files. And then in the later ones, when we run this, you can see this one is you can see the cp.yaml. This is particular for the control plane node. That one will change later to a worker node, and then we'll provide the command line a little bit further down when we do the install. Okay, I'm going to stop there because Sigo had mentioned this is extremely important because we need to make sure that the environment is ready, and then this is how we set up the Ipxe for this. So was any of that unclear, or maybe you have a couple of questions around why we structured that way? We're happy to take some of those questions right now. Says
cloud and IT. Yeah, cloud and IT will do most of the job, but not for the Talos for now. But probably we will look into that option later. Yeah, seems clear.
Cool. Okay, so if no one has any additional questions, I will move on to the next part, which is just basically installing the Talos, which is more or less straightforward. Okay. So for the machine config in the YAML file, this obviously the machine configuration is in YAML format. It'll be sent to the server for the Ipxe booting, and the Talos CLI tool can help to generate this file. So above is the command usage. Below is what we actually use based on our setup. So we put it as my demo as a cluster name, and then the 10.7.7.104 for the control plane, and we put the API endpoint. So for the control plane node interface and the IP settings, we want to bring up NAT on 10.7.7.3, which is the admin workstation. That server is going to be able to pull from the internet. So one thing to note, all of ZenLayer's bare metal servers have one internet interface by default, and then you can bring up the internet address with the same YAML file to bypass the NAT if necessary. During your Ipxe boot, the server will initialize requests from ETH0, which is the default first option boot of the ZenLayer bare metal servers. It will get the network boot image and YAML file via HTTP, and then do an initiate soft reload and apply the YAML file. By then, the internet interface will be up and running, and the installation procedure can start pulling the latest Talos image via the internet. So below, you can see one of the printouts for that. Anything special about that, Siegel? Yeah, it should be straightforward.
Yes, that's pretty straightforward.
Okay. The other piece is the name server settings and disk configuration. Usually it's sitting under dev/SDA, and we changed the wipe option to true. There's a little format the disk and load Talos Linux into it. And then once again, output for that. So one thing we wanted to note for the worker node interface and the IP settings, as mentioned, whenever you spin up the bare metal cloud servers on our side, you can go in and pull the IPv4 addresses, and then you can assign them in the YAML file, and those can all be pulled from the console.
Yeah, and I just want to pitch in for a quick suggestion, because we don't offer the Talos installation via the web page. So that's why when you place the order of our bare metal cloud, you will choose no OS option, so which will make sure you will get the IP address pre-configured on our switch. And then these IP can be used on your server, can be shown here. And then you can get the necessary information like the IP address as well as the MAC address of the interface. And then you can use that into the YAML file. So just a suggestion.
So it'll be a little bit easier to do that install.
Yeah. So Stephen asked a question regarding the CAPI, Citadel metal. Yeah. So that's something we can talk about that later. Yeah, because it requires like that direct IPMI access. And then unfortunately, on our console, so we do the reverse proxy for the web-based IPMI access only for now. But definitely that's something we are going to do down the road. Probably we are like the RESTful IPMI API call instead of the IPMI direct access. Yeah.
Very cool. All right. So with the internet IP address and gateway information acquired, change YAML to match the bare metal server internet settings, and this will let the Ipxe server do the network boot. and all the remaining image and installation should be done via the individual server's internet connection. So this is another interesting one with the Ipxe and the Ipxe booting and etcd bootstrap. So with the administrator's workstation and YAML files ready, you can reboot the first server for the Ipxe installation. The cp0 YAML in the boot script as the control plane node has to be the first server. And then you're going to access the server via the IPMI interface via the ZenLayer console so you can see the process. So the remote console is going to output showing that the server got the DHCP assignment and start loading the network and booting the image. Should start the installer and wiping the disk in the /dev and /sda folder. And then what end up happening is it will stop at the etcd and wait for a special step that's called bootstrap etcd.
Yeah, that's the key.
So once it asks for this, then we have to go through another series, and that's why we set up that admin workstation in order to facilitate this and then keep everything within the private environment. So as mentioned, the bootstrap etcd in a private network, what you're going to have to do after that is log into the administrator workstation. That's the 10773 in Siegel's lab, and execute the below commands, where the 1077104 is the control plane node. So you'll run the Talos CTL with the config with the endpoint 1077104, and then the config node for 1077104, and then hit the bootstrap. So this is a required step, has to be done only once during the first control plane node installation. And after that, you don't need to do this again. So once the installation is finished with the task, you can retrieve the config and merge it into the kubeconfig with a single command line. The Talos config file that's generated in step 4, you can run the command on administrator workstation as below. So you can use the kubectl or for the Kubernetes cluster management. Okay. So with the Ipxe install of the worker node, all you have to do is change the boot script file to dispatch the wk.yaml file, whatever you named it, and reload the worker nodes. So you should see below, it's the talos.config equals http 10773/wk.yaml. And then what you'll end up seeing is on the top left part is the screen output for the worker node installation. And then a terminal window in the background here shows that the node's registered successfully, but it shows that it's not ready for now. So what do we do? Let's take a short coffee break. And then you just wait while it does the install. Once it's done, the status will change to ready, and you're pretty much good to go. So those are just some of the interesting things we kind of ran into while we were installing Talos on the bare metal, and then leveraging our Ipxe environment and VLANs to run that in our private environment. When you look at automating and scaling of the Kubernetes, we have a couple things that can kind of help with that. Our bare metal cloud supports API calls, and also we support Terraform. That will be live, I think, in about a week with a plugin. And then that allows you guys to spin up the BMCs and kind of do what you need to in order to run that cluster. When you do that, you can pull the new the IP addresses, revise the YAML files accordingly, or run any scripts you need to spin up additional BMCs as the worker nodes. So that should help with automating and scaling. So once again, wanted to point you guys back to Siegel's blog post. With ZenLayer, it provides a little bit more detail, and then it's in his words, which is much better than mine. So if you need to do anything, you can kind of look over there and see what's going on. And then the other thing I wanted to kind of highlight is we're piloting a project to connect the Talos environment with either AWS or another hyperscaler, most likely AWS, via our direct connect circuits. So if you've already done this, or you're interested in like kind of helping us POC this and do that, let us know. We're happy to kind of work with you and then work through some of the architecture, as well as kind of see what happens when we do that. Contact information is there for you guys below. And now I would love to open this up to questions that you guys may have. And shamelessly, just let you guys know, we have 290 pops, 5,400 global peering, about 50 terabits of capacity. That's our global footprint that is connected by our backbone, as well as all the local IP transit and whatever we can do to help deploy this at some of these edge locations. So I will leave it there. Are there any questions? So I think there was one. Let me see.
Yeah, I saw there's a question from Peter.
Yeah.
Regarding the question of the bootstrapping step, is it similar to the kubespan? And I haven't tried that yet, but it's going to work with the same way as like the regular etcd bootstrap. And then you can choose to like if you define the YAML file to use the private network for the node communication. So basically, the bootstrapping will happen on like the private network. But if you put the internet address into that YAML file, and then after the control plane picks up the control plane YAML file, it will assign the corresponding IP address to the public interface. And then you can use like the kubectl or the Talos control or Talos CTL to do the bootstrap. But I will look into that kubespan option later. Then I haven't played with that yet.
Yeah. So in other words, Peter, just reach out, let us know. But Steve says it shouldn't affect it at all, which is good.
Yeah. Thanks, Steve.
And then Steve had asked, how long does it typically take to install Talos and have the worker be ready on our hardware? How long does that take?
From my experience, so for like individual node setup, it will take approximately like 25 to 30 minutes for each node. But you can like run multi-nodes installation at the same time, especially for the worker node, because the worker node will share the same worker node file.
Yeah, so you can run it concurrently about 25, 30 minutes to install. Yeah,
so probably like you can change the script file and then to make sure there will be like worker node 0 and then to worker node 1, 2, 3, 4, and then match the IP address to make sure the corresponding machine will be able to pick up the right worker node file because it has the different IP address assigned in that YAML file.
Yeah, and Eric's asking, how does this compare to Civo Cloud and Equinix?
Equinix is moving like one step further comparing to us. So actually, we are working on like the customer can upload the YAML file, and then we will do the provisioning of everything. So that's our like the feature we are working on, and then it will happen on our console down the road.
Yeah, which will make it very similar to the Equinix one. They can self-provision and deploy. Yeah. I would say it is a little bit more manual right now than them, but one of the main reasons for that is we just have a lot of nodes in different regions, especially like these emerging markets, where it's a little bit more difficult to kind of do that. And as we work closer with the team at Sidero, we're going to try to optimize and make it a lot easier, which includes what Sigo had said, allowing the YAML to be input directly through that console, and then just spin them up so you get a similar experience with them. About the long install times.
Yes. So because most of like the Supermicro based server, it will take approximately like 3 to 5 minutes to boot up, and then do the post check of it after the BLS hand over to the booting for the like booting up the PXE booting section. So that's why.
Yeah, we run some. It's not too beefy, but we got different mixes. So like with the small machine, there may be just 4 to 6 cores, 32 gigs of RAM. Those will probably boot up a little bit faster. But when we look at the larger machines, these are usually like Dell machines that are running Intel, either silver or gold CPUs. And then they have a little bit more RAM and different hard drive configurations and everything else. So I think those take a little bit longer to spin up the Kubernetes clusters.
Yeah. You're right. Thanks.
Very cool. Any other questions that we can kind of help out with?
The bridging extension into Amazon, do you have a specific use case for that you're designing it around?
What's funny? We just happen to have a lot of these cloud on-ramps. So by the end of May, we're looking to have about 200 cloud on-ramps into like 5 of the major clouds, right? So the AWS, Azure, Oracle, Google, and then I think it's the Ali's cloud, right?
Ali Cloud.
Yeah, Ali and
Cloud.
Tencent. So with those guys, the question on our side was like, well, with the Kubernetes and with Talos as well, they're going to bridge it across a hybrid environment. We just want to see what that's going to look like, and then we'd like to test it out with the AWS first. Even though they have like EKS Anywhere, that's a different thing, right? So we like to see how that works with Talos. I think that would be a lot of fun, and I think additional with the Omni, like what's the difference, when we kind of look at that. So there's a lot of experimenting that we want to do to make sure that everything works and it's kind of easy to deploy.
And this will effectively mean a subnet is shared across your 2 clouds. Is that correct?
And that's one thing that we want to kind of find out. I think because it's direct connect into the AWS environment, like you said, this is a private subnet. They can share the subnet.
Yeah.
Because they're all going to be, they should be in the same DC, or at least they're connected by the direct connect, right? So that's something interesting.
Yeah,
it should be fun.
Yeah, and then the best practice for like multi-cloud deployment will be like running over like layer 3 connectivity, because like layer 2 will be ideal for like point-to-point connectivity. But when you have more than 3, so layer 3 SDN-based solution will be like a best fit.
Yeah, I mean, and if you're doing that, you don't need kubespan because it's already protected by your SDN. So, yes, Spencer agrees.
Yeah, we do too. In theory, that's what we're thinking.
But theory and practice are the same.
Absolutely. So that's what we're saying. If we're reaching out, if anybody is has a requirement for this or is looking to kind of do that, love to kind of POC it with them, and then that way I can spin up some more resources for this instead of just like throwing everything onto.
Well, actually, our next talk, Tremor Video, I think they've talked about doing things very similar to this. So maybe stick around for their talk and then ask them about it at the end.
That might be a good way to do it.
Yeah, the next talk is, in fact, Tremor Video talking about their move from the cloud to bare metal, and I think that they have or plan on implementing bursting back to the cloud. So something like this is kind of them. So that's in 2 minutes.
Okay, sounds good. Looks like we finished pretty much on time then.
Yeah. So thanks very much, Wade Siegel. That was awesome. Andy just says, we have on-prem, AWS, and as of this week, Azure nodes in a single cluster using Talos. And it looks like one big subnet. Nice.
Yeah, the caveats, once they have a few things set.
A few things, minor details.
Absolutely. All right, this is great. Well, thank you guys for inviting us. We really enjoyed this talk. I think it's a great audience. Love to just stay plugged in and then see what else we can do to make it easier for the community.
Yep, really appreciate it. Thanks a lot, guys.
Absolutely. Thank you.